Hi, and welcome to our CS221 final project presentation. My name is Jack Zhang, and I'm here with my team, Flora Yuan, Anya Zhang, and Bowen Zheng. Our project is on characterizing misinformation, exploring linguistic patterns in fake and real news. In this presentation, we will first introduce the problem we're solving, the challenges we face, and I'll detail our approaches, and then finally explain our results and analysis. The problem we are trying to solve is that political statements spread very quickly online, and it's not always clear which claims are true, misleading, or completely fabricated. Also, human fact checkers cannot possibly keep up with the volume and speed of a misinformation spreading. So the solution is if we can build models that automatically flag questionable claims, they could serve as early warning systems. And our project explores whether machine learning can reliably detect fake political claims based on only the text of a statement and simple metadata about it. We also explore where these models might succeed or break down. In our project, we first reviewed the literature. Then we've identified our data set, which is the Liar 2 data set found on Hugging Face. Then we train our baseline model, which is a logistic regression classifier trained on TF-IDF representations. Then for our main approach, we added three additional sources of features and information on top of the logistic regression model. And finally, we looked at results analysis.
This slide highlights several challenges in detecting misinformation. Short and ambiguous statements often give the model very little context to work with. The subjectivity of truth is another issue, since labels can depend on interpretation or evolving facts. We also face topic imbalance, with certain subjects appearing far more than others. Speaker bias can arise because credibility features help accuracy but may penalize newer speakers. Models can also be misled by stylistic tricks, where emotional or exaggerated wording looks like misinformation. And finally, generalization is hard because models trained on fact checks don't always transfer well to real-world unseen claims. Here are the core approaches we tested. Our baseline model uses word-level TF-IDF to represent each statement and a logistic regression classifier for binary prediction. This gives us a simple lexical reference point. Our main model builds on that by adding 1 to 3 word n-grams and two kinds of contexts, speaker credibility and basic linguistic features such as sentiment and length cues. We still use logistic regression, but with a richer feature space that captures more detail about how political claims are written. Our enhanced model extends the main approach with even broader signals. We add character-level n-grams, additional linguistic indicators, and a richer version of speaker credibility. Instead of relying on one classifier, we combine three: logistic regression, SVM, and random forest, in a weighted ensemble. This lets the system benefit from each model's strengths and reduces errors caused by any single classifier's biases.
Here is our model performance results. We can see our baseline TF-IDF plus logistic regression model reaches about 68.5% accuracy, but it struggles especially with short or ambiguous claims. And then our main model offers a moderate improvement at 69.8% accuracy. However, the ensemble, which combines both word and character level TF-IDF with linguistic cues and credibility features, makes a substantial jump to 78.3% test accuracy. Most of the gain comes from better recall of true statements, meaning the model reduces unnecessary false alarm classifications. Here's our confusion matrices. When we compare them, we can see that the enhanced model correctly identifies far more true statements and fake statements than the baseline, and the enhanced model not only lowers false positive, but also improves balance between precision and recall, reflected in its higher F1 scores across both classes. In contrast, the baseline model mislabels a large share of real claims as fake, which limits its reliability in real-world use. Finally, looking at topic level performance, we see large gains in politically complex areas. Elections improved by nearly 18% points and taxes by over 11 points, but some high misinformation topics like Facebook fact checks tend to get overflagged as false, revealing a subject-specific bias introduced by the additional contextual features. The key takeaway is that adding content through linguistic style and speaker history significantly boosts detection, but it also creates uneven performance across topics, reinforcing the importance of careful, responsible deployment.
We found that overall adding context beyond the words of the statement themselves consistently boosts performance. This can be seen in the baseline where it struggles with short and ambiguous statements, but the main model improves significantly once we include who said it and basic linguistic cues. Also, the biggest gains have come from stylistic and structural patterns. Advanced linguistic features and character level signals have helped detect exaggeration, emotion, and sensational wording in the statements. And this kind of ensemble learning reduces mistakes from overfitting to any one feature type. Furthermore, performance is very topic dependent. We see large improvements in complex political topics, such as on elections, taxes, and immigration topics, while some high misinformation topics get overflagged and shows model bias. Finally, our models can inherit bias from fact-checking datasets, and because the model learns what the journalists tend to fact-check and not just what is true and what's false. This means that strong prediction doesn't necessarily equal objective truth, it just reflects patterns in the data. Thank you for listening to our presentation.